Alright, so a wave has a frequency of 540 hertz and is traveling at 340 meters per second. What's its wavelength? So velocity is 340 meters per second. Frequency is 540 hertz. And lambda, we do not know the wavelength. So let's plug it in. So V equals F lambda. Velocity is 340. Frequency is 540. And then lambda. So let's solve for this. And I'm going to leave some space over here so we can do our long division. So we've got 340 equals 540 lambda. And I know I'm going to have to divide by 540 on both sides, right? Because I'm trying to get lambda by itself, 540. Okay, so I'm left with, on this side, just lambda equals, a little bit crazy with the loopy thing, 340 divided by 540. Okay, and I like to always find shortcuts on these, and I'm looking at this right now, and I'm not going to call it a shortcut, we're just going to call it a smart cut. One of the things we can do is we can simplify this fraction as it stands. So we don't have to deal with dividing two three-digit numbers, which is way, way too much. We can simplify it at least 2 times, I see. There's 2 zeros here, yeah, and then we can divide by 2 even after that. Okay, so 340 and 540. So if I divide both these by 10, essentially I'm crossing out zeros. So I'll get, and I'll write this over here, so 34 over 54. Alright, and then I can divide this by 2, okay, because they both end in an even number. So divided by 2, divided by 2. So I'm going to get 17 on top. Okay, and then 54 divided by 2 is going to be 27. And that's as far as I can go. Alright, but now this division is going to be way, way easier. So I'm trying to find out how many times 27 will fit in 17. And it's not going to fit in 17 at all, right? 27 is bigger than 17. So we'll start out with our decimal here. We'll add a 0. And then we know it goes into 17 0 times, so we'll start there. So no matter what, you could probably cancel out answers in the exit slip. If you get to this point even, you'll be able to cancel out some of your answers before even doing any math, really. So 27 goes into 170. So I think we're just going to have to estimate first and then do some multiplication. So I know that 27 is pretty close to 300, or 270 if I did this by 10. It's close to 300. And 170 is close to 150. It's going to be around 5 is my guess. It could be 5 or 6. Let's try it both ways. So let's do 5 times 27. 27 times 5. 27 times 5 is going to be, so I'm going to get 5 here. It's going to be 35. 5 times 2 is 10, 13. So 135. Let's see. So I can definitely go 6. Okay, because 135, if I add 27 to that, it's still not going to give me 170. So 6 times 7 is going to give me 2 with 4 left over. 6 times 2 is going to be 12. And I have the 4 left over, so it's going to be 162. Subtract. 170 minus 162 gives me 8. Alright, we'll erase the math that we did over here, so we've got room for this. And I want you to go to at least two decimal places here, especially if you've got nothing on the other side of the decimal point. Okay, so 8, we'll add another 0 right there. 27 is, so it's probably going to be, let's see, if I do 3 times 2, I'll have 60. But 3 times 7, I'll have 21. That's going to be more than 80. So I'll do times 2. So this is going to be 62 right up here. 2 times 20 is 40. And then 2 times 7 is 14. So it'll be 54. Okay. 80 minus 54. Yeah, right. 7 is 1. So I'll get 6. And it'll be 26. And we'll leave it like that. So now I've got lambda, man, this is a fun problem, equals 0.62, 0.62. And lambda is usually measured in what?
Hertz. Oh no, I'm sorry, meters.
Yep, meters, right? We're talking about wavelength. We're talking about the length of each of these waves. So 0.62 meters, that's it.